All right, we are back to talk about enzymes this time. And so the I can statement is I can explain what it means to say an enzyme is a catalyst. Well, a catalyst is anything that speeds up a chemical reaction. And so what you see, or what you might see, is a chemical reaction where this is time and this is product formed. What you might see happening with the regular reaction is this. But when you add an enzyme, you speed up the rate. So in other words, you get more product. Let me label that so you'll know what I'm talking about. You'll get more product faster. So you're getting your products rising at a lot faster rate. And that's just because enzymes do work to facilitate chemical reactions. And they do that. This is the second I can statement. They do that by lowering the activation energy. So there is an amount of energy that is required to get a chemical reaction going. And so this would be your reactants, this would be your products. And this amount of energy that you have to get to is called the activation energy, or EA. Let me zoom in a little bit. So that's the EA there. And so what enzymes do, so this might be a regular one, and so what an enzyme does is it, sometimes, and it does it different ways, it may put strain on the substrate. So if the substrate is going to break in half, it might be that it kind of bends the substrate, so that kind of puts a pressure on it. There's all kinds of different ways enzymes work. But what you might see is when you add the enzyme, so this is with enzyme, you lower that activation energy, you lower the amount of energy that needs to be put in, and that's why the reaction can happen faster. So those are the first two I can statements. The third says, I can describe how the structure of an enzyme is related to its function of altering the substrate. Okay, when you look at an enzyme, there is a part of the enzyme, so this is the enzyme. There's a part of the enzyme that will bind to the substrate, and that is called the active site, because it is the part of the enzyme that is actually doing something. All of this back here is just structural. It's just here to hold the active site in place. The active site is a particular structure in order to fit the substrate. And it not only fits physically, so like puzzle pieces, but it also fits in that if this is nonpolar, then this is going to be nonpolar. Or if this is polar, then this is going to be polar. If it's positively charged over here, so let's say we have a little positive charge sticking out here, because enzymes are not always, but mostly proteins. So you've got those functional groups sticking out. So let's say that you have a positively charged functional group sticking out there. You're going to have a negatively charged one sticking out there. So they'll be attracted to each other. So it's not only the shape of the active site that matches the substrate, it's also the chemical properties of that active site. So the polarity, the charge, all that kind of stuff. And so it is structured specifically to fit with that substrate and to do whatever it needs to do. Like I said, it may cause the substrate to kind of bend like that. And so it creates some strain that will eventually cause that substrate to break in half. Different enzymes do different things, but so it's going to fit. It's going to bind to the substrate at the active site, but it's also going to be structured so that it can perform the function it's going to need to. I can explain why enzymes are substrate specific. So most enzymes bind to either only one substrate or a class of similar substrates. But there aren't really enzymes that bind to just anything. So you don't have an enzyme that'll bind to a sugar and a protein and a nucleic acid or any of that. I mean, they're specific, more specific than that. And the reason is, going back to this active site and this structure, it is built specifically for its substrate. So if a different substrate, if this kind of substrate came in, well, that's not going to fit in here. So this substrate would not bind. It would just pass on by. And then the last is I can contrast a lock and key and induced fit models of enzyme-substrate interactions. There are two real models of how we think enzymes and substrates interact. The first is the lock and key. So that's the enzyme. I didn't really make it an E on purpose. Then this would be the substrate. Okay, and so they literally fit together with a perfect fit. Okay, that's the lock and key. Just like your key to your house fits only your lock. Hopefully, if you took your key to your neighbor's house, it's not going to open their house. So that's what it means. It's a lock and key. It's a perfect fit, and it doesn't fit other things. Induced fit, and we really think most enzymes are actually like this, and this is why some enzymes can bind to more than one substrate. They can only bind to similar substrates, but they might bind to maybe 2 or 3 different types of sugar instead of one, is this induced fit. So this is our enzyme and this is our substrate, and what happens is the enzyme will change shape, not drastically, but like this one's just going to kind of curve out to bind to that substrate, and so that is the induced fit. To induce means to make happen. Most of us have only heard that word with pregnant women. So they induce a woman to go into labor. They make that labor happen. Induced fit means you're making that bonding or that matching happen. So those are the 2 models. Lock and key, perfect fit from the get-go. Induced fit, also a perfect fit, but the enzyme has to change shape to get there. And so that's just kind of an introduction to enzymes, and I hope that helps. If you have any questions, let me know.